Hi guys, this what you see is a car starter motor, and that's the gear that gets in contact with the engine of the car and starts it. It can draw current up to 200 amperes depending upon the thickness of engine oil. Usually it is 100, but in colder regions it is 200. And that's the solenoid that pushes this gear upwards. You see, it's coming up and down. That electrically happens with this. So guys, here I'm going to show you the continuity. 283 kilo ohms, which is negligible. It should be even less than half ohm. Yeah, now it is mega ohm. This shows that the motor armature is dead. Now I'm going to show you the continuity of the solenoid. Even the continuity of solenoid is going to be higher than this one. Yeah, here as you can see that the continuity of solenoid is only 1.4 ohms. Less number of turns and thick wire has been used here, and even thicker on the armature. Let's see the problem and open it up. And then you are going to need an 8 mm bolt opener. That was easy. That's the cap. It's really rusty. Keeping it aside, I have a lock. That's out too, and a spring. Before taking it all off, also open this bolt, because the wire from the actual motor is connected to the solenoid. So the back cover is out at least, and the first thing to note is that there are no bearings, only bushes. It's clear guys that there is no damage to the commutators, and they are also healthy, and the brushes too. You see, they are not even worn out. Both of them are live here as well as this one, and neither are they broken. Now let's open it further to see and find out where the fault is. Although as you can see here that the brushes are really thick, obviously to carry huge current and feed it to the armature. Now guys, to take out the armature and the rest of it, I think I will have to open up the solenoid. So guys, your hidden question for today is, which transistor did I use for the demonstration of the inverter in my previous video on breadboard? So that's the solenoid. Finally it's out. That's the top case. Now let's take off the armature as well and the field. Yeah, it's like this. Yeah, it moves it like this. Pretty cool, right? And look at this part. Where it moves up, it rotates to some degree because of these lines. I don't know why didn't they give a simple up and down type of lock. Oh, they also had to like jam it with this, like it's not moving, and the solenoid pushes it upwards like this, and then when the armature rotates like this, it gets jammed. If there wouldn't be any threads like this, it would be freely rotating, and that's the stopper at the top. Without this, it's gonna come out. And that's your armature winding. Super thick copper wires have been used, and very less number of turns. I think only one turn. So it's wrong to say turns. Only one turn per pole. Although there are too many commutations, so the number of poles are so many, but the number of turns per pole is just one. Now guys, after close inspection, I think I found out the problem. There is no problem with this armature or rotor, But there is problem with the stator winding. First of all, this motor has been repaired previously, because we can see here black tape placed by a bad repair person. There is another problem, that he pressed the winding towards the wall so much that the end point from this pole, this one, is under a short circuit with this one. There is no gap left in between the two, so they are both contacting and creating a dead point for this pole, so it will not activate and the current is just going to flow from this part to this part, and hence the motor is not going to run. Plus pretty bad points here, all winding fully open, so I will have to improve upon all that to get it started. This guys, finally the bad insulation was removed, and I'm going to replace it with the proper one. And I also have to separate these two. So the stator repairing part is complete. Let's start with the checking. One terminal is this one, the other one is this. And here we can see that the winding resistance is only 0.8 ohms. Obviously, because these are copper and very thick, so they can carry huge currents and hence low resistance. And there is one more important check, is to see if there is any connectivity between any of these two terminals and outside the body of the starter motor. If any of the two wires is in contact with this, it's going to create short circuit and battery damage. Here, as you can see, that it's showing resistance in mega ohms, so we are good. There is negligible connectivity. Well, I could not achieve enough temperature with the soldering iron, so I had to use butane gas, and now it is pretty strong. Cool. So let's assemble it back again, and I will also have to remove this clip. Yeah, now it seems fine. The springs of the brush are so tight, it is really difficult to hold them back and then place them on the commutator. Finally, it is assembled back as before. Now it's time to test it. Well guys, I tried to run this motor with my 7Ah UPS battery. It didn't even move. There was only sparking. So finally I thought that I need a bigger battery. Now let's connect this Amaron battery. I think it should work now. Okay. One wire done. Okay, now all I have to do is connect this terminal to the body of this motor. Now just like a car alternator, the body of this starter motor is also one terminal and positive is like here. Okay, starting it. It's not running. Let's see if the battery is okay at least. Yeah, bulb is glowing. Okay, now. So guys, as you saw that I gave it so much try, but then I had to open it up once more. And finally I found another major problem in between the rotor winding and the commutators. Here as you can see that the copper wires from the winding of the rotor are coming here and joining at every single commutator, one for each. But in some parts you will see little gap like this one, you see, and similarly others. So what I'm going to do is I'm going to do resistance check. So now I'm going to do the commutation check. This is one bar and the one next to it is another. So placing one on the first and then on the second. Here as you can see that it's 1 ohm. Let's move on to the other one. This and this. It's 0.9, almost the same again on the other. And you see that this one is in kilo ohms. So it's like there is no winding contact in between these two. It's open. Let's come on the next one. 1.1, 1.2. It's a minor failure, but still it is available. 8.4 ohms, a little higher failure, but not a major one, but it is there, so needs repairing. In reality, each of them should be at 0.9 ohms. So seems like the bars have been desoldered from here, and this is creating a problem for the rotor. So I will have to solder them back again. Oh guys, finally I've understood the full problem this DC motor starter motor faced. Actually, if you look closely at the commutator, this part or this surface, it looks like it was rubbed on some surface. You see, because of which these commutator bars stretched to this side and this side according to the motion of the motor. At some points, it is even making contact with the commutator next to it. You see, and there are lines of it being rubbed against some part of the motor. So because of that, super high friction was created and these solder points melted. And because the motor was rotating at a very high RPM, so the melted solder moved outwards because of the centrifugal force, and it got automatically removed. And why it happened? Because when I opened up this starter motor, there was no metal ball here, because of which this rotor was little more downwards, and hence it was getting in contact with the base side of the motor casing. Because of that little ball, it would have been at a little gap with the base. So the removal of this small ball caused so much problem. It's quite easy to understand now. So here I'm creating space between the commutators with the help of my razor, something like this. And I will do it on all those where I see that they are getting close to the other one, and until the resistance of each commutator next to it becomes equal. Now, while applying the solder, make sure that you do not connect the two different commutators together, because then it will create the shortest path for the current flow, and the current is not going to flow through the winding but to the commutators themselves, and creating another problem for your motor. So that's one commutator, the one that you can see, and then that's the other one. And this joint, this slot is not to be soldered. These are two different commutators. So let's apply flux accordingly. So let's show you the soldering first, and then I will do it myself. So that's the first slot that I'm going to do. Keep it held over here for some time. Okay, one seam's done. So this is how you are going to do it on each one. Now the second one. Now you see this one is coming on the third one, creating a short circuit, so I have to remove it. So after soldering these points, it looks something like this. And at some points the soldering jumped from this commutator to this one also, and I had to separate it with the help of my razor. And after checking it, it seems fine. And now the resistance of each bar is almost 0.8 ohms. So guys, for the closing part, you see here, okay, you have to place the spring like this and then the lock, and it's done. You see, if I push it, it is going upwards a little bit. That will be done with this little ball from an old bearing which was missing in this, because of which the entire piece got damaged. See, there is a groove given for the ball. This much is done. Now let's complete the rest of it. So guys, after completing all the assembly, once again I'm going to test it, and here I have also placed this 12 volts bulb to check the connectivity. So when I connect one wire of the motor to the battery, the bulb is glowing, which means that the connection has been established perfectly. Now finally it's time to do the test if it runs or not. Okay. Oh, the wire came out. The spark was really heavy. Because the motor is obviously high current type. Once again. Oh, sorry. It's really heavy. Oh. Okay. It's running. It's running pretty good. Right, very smooth. I'm so happy that I finally repaired it. It had so many faults in the commutator, in the rotor further parts, plus your field winding. Everything was it was like the motor was completely irreparable. It was really difficult. It was a really difficult job, but now that I have done it, I feel so good. Once again. Oh, the wires are red hot. I never had a car starter motor. All I had was bike starter motors. I never bought it, although I could have, because they use huge current, which makes them not much usable for projects like e-bike. I saw some videos on people making e-bikes with a starter motor. They take so huge current that it is just foolish to make e-bikes or go-karts with the car starter motor. The better way is to convert car alternator into a DC BLDC motor and then use it, instead of going through the car starter motor. 200 amps, it's going to kill your battery, and it is not designed to be used for such longer durations. I don't know why they do it. I think it's just for show, but anyways. Well, what I'm going to use this for is usually load testing. Let's say I've made like buck converter, high current buck converter. I can test this motor to get an estimate of what kind of loads it can run, or if it can handle huge loads like that. Okay, once again. Whenever I connect the wire, I get really scared. I'm enjoying it so much. So anyways guys, I believe you people learned how to repair a starter motor and what kind of faults we can find in a car starter motor. I think this motor has covered all types of faults, almost all types of faults, except for the solenoid was perfectly fine. So thank you so much for watching this video. Hit like, don't forget to share and subscribe, and if you have any queries, you can always ask them in comments.